Okay, so Vijay, can we start with your fluid mechanics for Bhava Atomic Research Center?
Yes, sir.
Mhm.
Yes, sir.
Okay, so you know what is capillary?
Yes, sir.
Hmm. What is that?
Sir, capillary is the rise or fall of liquid due to the property of surface tension of liquid.
Hmm. Why there is a fall?
If the diameter is very small, of the order of millimeter, then water will rise to that.
And why the water will fall?
Sir, if the theta is more than 90 degree, for example, for mercury, it will fall.
Hmm. Okay, in which case mercury will rise and water will fall? Getting any idea, Vijay?
Yes, sir. Sir, if the cohesive force between the molecules is lesser than the adhesive force between the substance, then I think it will fall for water.
But why in mercury there is a fall in mercury level in the capillary?
Sir, because the cohesive force between the mercury is very high, sir, as compared to the adhesive force between the mercury or with any other metal, any other material.
That's okay. That's okay. But how does it fall then? What is the mechanism behind this fall dip in the mercury level?
Sir, I'm not sure.
Hmm. Okay, now let me ask you how capillary and surface tension phenomena are linked.
Yes, sir. Sir, can I make the derivation?
Yes.
Yes, sir. Due to surface tension, the liquid will rise because there will be some vertical component that will be acting that will be responsible for increasing height.
You have made some kind of diagram here.
Yes, sir.
What diagram? Show me what is the diagram you have made. Okay, so no expression which you are making. What is the expression you are making?
4 sigma cos theta divided by rho GD, sir.
Hmm. What is rho into G? What is that term called?
It is called specific weight, specific weight density, sir.
Weight density, huh?
Yes, sir.
So how do you draw the graph between mercury rise and weight density? If rise of the level of mercury versus weight density is to plotted, how shall you do that?
Sir, the level of
How will you draw the graph of mercury rise and the weight density?
Sir, it decreases linearly, sir.
Hmm. Okay. So, surface tension should be high or low?
Surface tension should be low, sir.
Why?
Sir, if the surface tension is low, then the fluid will have a good wetting characteristics.
Okay. So, do you think mercury has low surface tension or high?
High surface high surface tension.
So, is mercury not used in various applications because of high surface tension? Now, take a capillary and let's say H is the rise of level in the mercury, in the capillary, rise of the water level in the capillary. Let's say that is H. Make a diagram.
Rise of mercury level. Sir.
Is H. Now cut this at H by 2 level. Cut this capillary at the level of H by 2.
Yes, sir.
What will happen?
Sir, it will not fall. I know that it will not fall, but I don't have the explanation. I watched it in the marathon video. You have mentioned it.
Okay. Okay, Vijay, let me give you the feedback now. Vijay, BARC typically question is like he will force you to think. So if you say there is a capillary fall in the mercury level, he will ask you why there is a fall in mercury level. Cohesive force is so high that mercury will remain with mercury, not with the glass. So mercury is
Yes.
in the lower side, so mercury will come down.
Yes.
Whereas adhesive force between glass and water is more, so glass will pull the water towards it, so it will rise.
Yes.
Now, water will fall like mercury only if the cohesive force of water is more than cohesive and adhesive force of tube. Let's say there's a tube with oil inside it, oily tube,
Yes.
and water में तुम डाल दो तो oil and water adhesive force is not good,
Yes, sir.
and then water का cohesive force will be more, and water will behave like mercury and the level will go down. Got it?
Okay. Yes, sir.
You need to revise that. So BRC is total thinking oriented interviews,
Yes.
right? So every question of BRC will force you to think. Again, like H
Yes.
rise कर गया, cut कर दो, diagram बना दो, plot कर दो, that kind of thinking you have to develop, friend.
Yes, sir.
You understood? Like mercury is dropping because cohesive force is more than adhesive. So water will drop only if cohesive force of water is more than adhesive force between water and the container of the material of the capillary. So make the material of the capillary such that adhesive force is less than cohesive force between water. That's it. Simple.
Yes. Yes, sir.